All right. Next topic. Cool. What could they be? Radical operations. Okay, so last time I said operations with radicals, which really was just simplifying radicals. Okay, so this one is radical operations. This one where we actually get to add, subtract, multiply, and, well, no, not divide. Just add, subtract, and multiply. Dividing is too hard for y'all. Right now, we'll stick to add, subtract, and multiply. Anyways, we're going to add, subtract, radical expressions, and then multiply. So let's look at this. How does this work? Well, let's add and subtract first, okay? Because let's do it. So to add or subtract, think of that as like a variable. Okay, so if you look at this, here's an example. Think of the radical as a variable. You can add those numbers together that are on the outside. So you're thinking of the 3 and the 5 as coefficients. So I'm going to say 3 plus 5 is 8. But you do nothing with the radical. So it's like if you were saying 3x plus 5x is 8x. So here it's just 3 plus 5 is 8, square root of 2. And that's it. You're done. Because you can add the 3 and the 5 together because the radical, the square root of 2 is the same for both. Okay? So how about something like this? 6 square root of 7 minus 4 square root of 7. Well, that would be 2 square root of 7 because 6 minus 4 is 2. And the square root of 7. Well, sure, what happens if they're different? Like 3 square root of 5 and 2 square root of 3. Well, there ain't nothing you can do with that. So the answer is just what the problem was. 3 square root of 5 plus 2 square root of 3. And that's it. So the idea here is they've got to be the same to be able to add. Now, how do I make this harder? Because you know I've got to be able to make this harder. I mean, this is Mr. Patch here. That's what we do as math teachers. We try to torment y'all. I'm kidding. Anyways, let's see here. Let's see if I still like this problem. Apparently I do. Okay. Because I've been... just go with it. All right. Okay, so look. Here's the problem. It appears I have 7 square root of 2 plus square root of 8. And that they don't match, so that's nothing I can do. Wrong. Okay, so let's look at this. Can I simplify the square root of 8? Well, yes, you can. And you find out, using what you should have done from the previous lesson, that the biggest square root that goes into 8 is 4, and you get square root of 2, and so square root of 4 is 2, square root of 2. So now I have it where they do match up. It's 7 square root of 2 plus 2 square root of 2. When you simplify, they could look alike. Yes, they can. All right, so 7 plus 2 is 9, square root of 2. Now seems like a good time to sneak in a little magic word. All right, so here we go. If you can give me and I'm going to have the next problem coming up. Show me in your notes before class starts that you wrote the word Christmas. Yeah, let's say Christmas. Then there might be a reward for that. Okay? But I won't going to tell you. I'll leave it a surprise. Anyways. Alright, so let's look at square root of 27 and 2 square root of 5. 75, sorry. Well, the square root of 27, if you look at your perfect square table, you would get 9 and 3. 27 divided by 9 is 3, and the square root of 9 is 3. So it's 3 square root of 3. Then you go to 75, you get 25 and 3. Now the square root of 25 is 5, and that 5 would be on the outside. It would have to multiply the 2 that was already out there, so 2 times 5 is 10. Square root of 3. Put a plus in between because there's a plus in between. Say 3 plus 10 is 13. 13 square root of 3, and you are done. Done. Yay. Alright, so let's look at another example. That's supposed to be a plus, by the way, not a times. I don't know why I have times, and I'll fix that in a minute. Okay, so notice here that 40 is 4 square root of 10 because you go through your square root tables and 4 will divide into it evenly. Square root of 4 is 2, so 2 times the 4 that's on the outside is 8, square root of 10. Then I got this 28, which is 4 and 7. Why do I feel like I need to change that? Hold up. And that would be 6 square root of 7. Okay, and 6 square root of 7, I had to kind of see it play out, so let me go. Because the square root of 4 is 2, 2 times 3 is 6, and leave the 7. 200 is 102, the square root of 100 is 10, so I get 10 square root of 2. Now look at these. None of these, now you know these are simplified and none of them are the same. So that is your answer. That's it. 8 square root of 10 plus 6 square root of 7 minus 10 square root of 2. You will leave it alone. Alright, so let me see here. Let this one play out a bit. Okay, so we got 2 square root of 98, which is 49 and 2. And the square root of 49 is 7, so 7 times 2, which is in front, is 14. Square root of 2. You got 18, which is 9 and 2. Square root of 9 is 3. 3 times 6 is 18. Square root of 2. And then for the 50, you've got 25 and 2. The square root of 25 is 5, so 5 times 5 is 25. So I get minus 25 square root of 2. So now I can go 14 plus 18 minus 25 to get an answer of 7. 14 plus 18 is 32. 32 minus 25 is 7. Square root of 2. And there's that. All right. So now let's look at multiplying. Okay, on the multiplying, there's actually a couple of different ways you can do this. Okay, so let's look at a problem like this. 50 square root of 3. Notice I'm not worrying about variables or anything like that right now. But 50 square root of 3, or 50 times, square root of 50 times the square root of 30. I was going to be able to say that right in a little bit. Okay, square root of 50 times the square root of 30. You can multiply both of those, because if it's multiplying, you can just multiply whatever's under the radical symbol. Okay, so 50 times 30 is 1500. Okay, then you could go through your tables and start working your way backwards. Now, to be honest though, if you're going to do that, your table actually should be up fairly high. I mean, half of 1500 is like 750, so you're looking at something around at least 24, 25. Well, square root of 25 is 625, so I mean, you would have to be really around 27, 28. Square root of 27, I mean, the 729 is square root of 27. So if you start working through it like that, I mean, eventually you'll discover that, yes, the square root of 100 will divide into it. And you get 15. And the square root of 100 is 10. So this answer is 10 square root of 15. Now, to me, this is where the factor tree might be easier. Or, let me rephrase that. Yeah, I think kind of the factor tree. And, you know, we can discuss this tomorrow in class. But 50 square, the square root of, like if I do the factor tree, I get 25 and let's say 2. And then that's 5 and 5. Or I could have gotten 5 and 10 and gotten 5 and 2. 30 goes 3 and 10 and then 5 and 2. Okay, so if I write down all these numbers that are right here, because I'm putting them together because that's the multiply. I got 5, 5, 2, 3, 2, 5. I just wrote them in order that I have them. Okay, so I can see I've got a pair of 5s. And I can see I've got a pair of 2s. Those would go on the outside. So 5 times 2 is 10. And then I've got a leftover 3 and a 5. That would stay inside. And 3 times 5 is 15. So maybe depending on the situation, it might be which one do you feel like would be easier for you to be able to do. And that kind of comes up to you. So keep that in mind. So there might be different ways of doing this. Okay, so let's look at this and let's try to go with a smaller number, because I think I'm going to do smaller numbers with this and not try to make it too crazy difficult. Okay, so if I just stick with smaller numbers like this, I can say, okay, look, I can multiply these numbers. 5 times 3 is 15. I can also multiply these numbers. 2 times 8 is 16, and x times x is x squared. That works out a little bit easier, because look, I can know the square root of 16 is 4. And x squared, the square root of x squared would be just x, because 2 divided by 2 is x, or 1. Okay? That would have to multiply the 15, because that right there has gone out of the radical. There was nothing left. There was nothing that didn't divide out, so I'm done. And so 15 times 4 is 60x. So let's say we're going to try to work with, say, some smaller numbers that hopefully won't be too taxing. Let's try this. 3 square root of 5y times 8 square root of 10yz. Okay, well 3 times 8 is 24. So I'm multiplying 3 and 8 to get 24. 5 times 10 is square root of 50. And then y times y will give me y squared and z. Now, 50, if I go through my perfect square tables, is 25 and 2. So this square root of 25 and square root of 2. Well, 25 is 5, So I could take this 5 times this 24, and that would be on the outside and give me 120. The square root of 2 would stay inside the thing. Now let's look at the y squared. Well, the square root of y squared, take the 2 and divide by 2, will give me y to the 1 with no remainder. Z, nothing that does not get, that can't be divisible, so it would stay under. And there we go. Okay, so that covers our adding, subtracting, and multiplying. I'm not going to try to do the multiplying much more difficult than that, but I will throw this one in. And maybe I'll put it into an assignment, but more than likely, I'll put it into 4 plus 2 square root of 5 bonus. So I'll give you some problems to practice with this, but consider that this, if it appears on the test, or when it appears on the test, it will be a bonus. Okay? Now, on something like this, I would definitely give it to you in a, what's the word? I would definitely give it to you in a simplified format. So there's not like these numbers can be simplified further. Okay? But let's start multiplying. Okay? So I'm going to say, and I'm going to do distributive property. 4 times 3 square root of 3 plus 4 square root of 5 times, or plus 2 square root of 5 times 3 square root of 3. So this one I'm going to use distributive property rather than say vertical method. For me that might be easier. So 4 times 3 is 12 square root of 3. 4 times 4 is 16 square root of 5. 2 times 3 is 6, but now I've got square root of 5 times 3 is 15. And 2 times 4 is 8. 5 times 5 is square root of 25. Okay, so now let's look. Well, this can't be simplified further. This can't be simplified further because 3 and 5 are prime numbers. That can't be simplified further, but this one can. What's the square root of 25? It's 5. So 5 times 8 would give me 40. So my final answer, it would be 12 square root of 3 plus 16 square root of 5 plus 6 square root of 15 plus 40. Okay? So I will look at that and give you some more, but keep in mind that would be for bonus. Anyways, that is it for now. I hope this helps you get prepared for the next lesson. Thank you so much, and y'all take care.